All right. So firstly, everyone, thank you for coming in. This is my first toolshed talk or first security talk ever. So I'm glad everybody showed up. And so my talk is about ClickForClickOnce. It's essentially a framework for creating configurable Clickonce payloads. We'll get into the terminologies of that as you progress through the talk. So for the last couple of months and a year, at Black Hills, we have been using Clickonce for initial access, shellcode execution, and a bunch of other stuff. And it has been really, really useful. We'll talk about some EDR detections down the line. And this is just a framework which automates that. Oops. Before we begin, who am I? I'm DB. I do malware development for BHIS. Previously, I was a consultant with Certus Cybersecurity in Payatu. And when I'm not working or looking at computers, I try to read a lot. I play a lot of Souls games, so that builds persistence. And I love indie cinema. So if you want to talk about that, you'll find me in the hall chit-chatting about that stuff. And I'm also a cat dad. That's my cat. I call her the chief code inspector. She was extremely judgmental throughout this whole process, and I hope to make her proud. So moving on. So what is Clickonce? According to the word salad created by Microsoft, Clickonce is a deployment technology that enables you to create self-updating Windows-based applications that can be installed and run with minimal user interaction. Essentially, before the days of Intune and we had deployments and stuff, organizations would send you a link and you can just install an application with that link. That's pretty much it. But we can use Clickonce as red teamers and penetration testers for a lot of malicious reasons. But another question is, why should we bother with this technology which was way, 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 way old? A couple of reasons. One is you can get, even though the name is Clickonce, it's a bit misleading because you get payload execution in 2 clicks from a user. And if you're on a social engineering engagement, those 2 clicks are a big thing. Second thing is Clickonce does not leave artifacts in the download folders, so that's less suspicious. Next thing is no smart screen blocking, because if you try to download an EXE or a DLL onto a user's computer, sometimes smart screen blocks that. In fact, previously at Wild West Hacking Fest, there was this amazing talk called Less Smart Screen, More Caffeine, which also talked about Clickonce, so I would recommend everyone checking that out. And the last one is it has comparatively less detections, something which we will talk about down the line. So coming up next, what is a Clickonce attack path? First, you have your Clickonce files. You deploy them anywhere. You can deploy them on an internal SharePoint folder, on AWS, pretty much anywhere. So once you have your deployments, you have your .application file. If you focus here, you will see right around this part, there is a .application file. Right. You send the link of that .application file to your target, whoever you want to phish. They open it, and there is the first click. There's open and cancel. So once they click open, they get the second click, which is like run, don't run. And provided you convince your target to click these 2 things, you get shellcode execution. So it's that easy. So now, what are the challenges with Clickonce deployment? Like, why don't we hear so much about it? Right. So one thing is, whenever you're on a red team engagement or something like that, you have very limited time. Assuming, let's say you have a 6-day engagement, 5 days are for testing, 1 day is for reporting. So during that time constraint, if you're a tester, if you have to go out and build your own payloads in a configurable manner, that's a waste of your time, which should be better spent on testing. Right. Also, payloads differ from ruse to ruse, from organization to organization, from individual to individual. So if you try to go for that customization, that also takes up a lot of the tester and development time. And final thing is Clickonce deployments are traditionally created using Visual Studio on Microsoft, which can sometimes make all the development a bit difficult to automate because Windows is not super great when it comes to automation as compared to Linux. So these are some of the challenges why Clickonce can be a bit difficult and to generate during engagements, and we don't see much of it around. But here's the solution. This is ClickForClickOnce. This is something which we have been using internally, and now it's open source right here. If you go to this GitHub URL, you will find the code and the documentation for it. And it's really easy to generate this thing using this particular framework. The step 1 is you clone the repository, you deploy it using one command, we'll see that. Then you configure the thing to you in a way which is more suited to your needs. And finally, you have that. You profit of it. So moving on. So this is just one command to deploy the entire web interface. And once you've deployed it, you get an interface like this. Now, I have a philosophy when it comes to designing malware development tools, is that at any point, a tester should not have to click between more than 3 or 4 buttons. Take away that complexity away from it. And most malware tools are very difficult to set up. You have to have a bunch of things. You have to download a bunch of frameworks, programming languages, dependencies. That takes away from the time of the tester. So I like to have a web interface so you can just go get things as easily as you can and take it from there. So once you have your Docker Compose up, it should deploy your application and you should get the web interface. Right, moving on. This is essentially the entire infrastructure. The user, we have the user, and inside the Docker container, we have a caddy server. The caddy server manages all the static files, and we essentially send an API request to a fast API server where the building, configuration, all of that is done. And once it's done, it zips all the artifacts, and then caddy serves it back to you. So going on, these are the options or the configurations which you can go ahead and generate. First is the ClickOnce name. So when you create a ClickOnce, it shows, if you pay attention to the red dot, this is what the users see. It's a name. So let's say you're targeting an ABC organization. You might want to name it something like ABC Task Sync, ABC Policy Updater, so that it makes the whole thing more believable. Next thing is inflate size. This is a very funny thing because we have noticed that in some cases, EDRs either do not scan files above a certain limit, or they don't immediately scan a file. So we have seen that it's somewhere around the 200 to 300 mark. So you can artificially inflate the size of your payload. Now this inflation happens in 2 steps. One is you inflate the text section to a certain limit, and then you add some random data values as a resource file. Because if you inflate the text section too much, it increases the entropy by a lot, which is also a bad thing. And if you inflate just the text section, you do not have enough randomization when it comes to the code itself, the text section where the execution happens. So it's a good balance between those two. So somewhere around, you can still configure it. It's open source, so you can just modify the values suited to you. But I would suggest keeping the text section inflation to 10 MBs, and rest can be the resource file. Right. Now, this is the next important thing. The ClickOnce application uses app domain injection to run the payloads. Why do we do it? It's because this way we can have something like a Microsoft signed binary running our shellcode without actually forcing some DLL injections and stuff like that. So right here we have 4 options. These are all Microsoft binaries. Most of them come from the Visual Studio Test suite. So we have TZ Sync, we have PowerShell ISE, which most of us are familiar with. We have Service Hub, and we have Perf Watson too. You can see here that this particular shellcode, it's a simple Hello World shellcode. It's running under PowerShell ISE. So this is something which might help with detections as well. And we'll talk about them later. And finally, we come to the actions part. Here is the part where you can add a bunch of actions to your ClickOnce to do whatever you want, because you might not always want shellcode execution. Sometimes you might want to drop files on disk. If you have been following BHIS's YouTube channel, Steve has an amazing tool called Bolt Hole, a repository out there where he demonstrates how you can use something like SSH reverse tunnels to get access to client machines without using a C2. So if you want to do something like that, you can use these options. So the first option we definitely have, shellcodes. Now, there's a trick here that the shellcode execution is delayed by 8 minutes. And why is that? Because last year we noticed that CrowdStrike and certain EDRs, they look out for RX memory allocations, and they'll monitor that region of memory for like 3 minutes to 5 minutes to see that, hey, is any network connection arising from this place, which is a signature of a C2. So that's why, just to be on the safe side of things, we delay all shellcode executions by 8 minutes. Next thing is dropping a file, because you might want to maybe drop a DLL to sideload or something. And finally, we have an option to run OS commands. Mind you, the file dropping and the OS command, they all support environment variables, just to give you that flexibility there. So that being said, here's a demo video. So first, we give it a name. We select one of the, I think we selected TZ sync, and we select a size. And then, oops, I went back. And I skipped it, yeah. So we use PowerShell ISE. We set a certain size. We choose all three options. So we have we are choosing the shellcode option. I think I choose a message box shellcode. Yep, I know myself a bit. Next is dropping a file. Again, the same file, and we place it in the temporary directory with anakin.txt because I'm a Star Wars nerd. And finally, the run OS command. And once you hit the submit button, it takes you to this URL, and there's a build.log file there where you can see how far the building process is done. As you can see, it uses Nugget to install everything and build your payloads. And once your payloads are built, you will find a zip file in the same parent directory where build.log was there. And that should be any second now. Yep. So you see, the zip file was created, and you can just download it, host it anywhere, and you should have your payloads. Moving on. Wait. Canva isn't showing my video here. That's unfortunate. Oh, here it is. So that sounds like a plane going off. Oh, now it's working. So you open Edge, you go to the place where your application folder is hosted. So here you click on the .application file. It gives you a prompt to open. It downloads the other manifests. You have your second prompt, the second button of ClickOnce. You run it. And I've disabled the 8-minute delay here just for the sake of demonstration. But you should have your shellcode execution right about now. So that's your MSG command prompt opening up. That's your shellcode running. And if we pull up command line, and if I can learn how to type, there should be an anakin.txt with 433 bytes of shellcode right there. Yep, so it did all the three things. We can configure it too. Now you can add more actions. You can sequence them. You can rearrange them in any order you want, and it should execute it. Next thing is, let's talk about EDR tests, water detections. So this is a bit tricky. In our tests and all the field tests we have done against EDRs, CrowdStrike and Cylance do detect this. And what gets detected, we'll come to that. But if you're going against MD, Sentinel-1, Sophos, we have had amazing success with it. I don't think we have had a single detection instance here. But let's talk about what gets detected. Funnily enough, it's not your payload which gets detected when you run it against CrowdStrike, Falcon, or Cylance. The way ClickOnce Microsoft handles .application URLs is using DFSVC, and somewhere during that process structure, there is a call to run DLL32, and that is the one which gets signature, not the payload, not itself. So that putting it out there, that it's not the payload which gets called. It's run DLL32. So if you're in a situation where you're against CS or Cylance, you can still take a shot, but here's the detection matrix of it. And that's pretty much it. Here is the GitHub URL to it. That's my Twitter. If you guys have any questions, or if you want to talk more about this product, feel free to reach out to me. Thanks. Am I before time or am I late? How many minutes do we have?
We have quite a bit of time for questions because the next session doesn't start until 2:05.
All right.
So
I finished early.
Any questions from the audience?
Yeah, sure.
So you mentioned that you disabled the 8-minute delay for your demo. Is that a configurable option with setup?
Yes, in fact, I can show it to you. Okay, the question is, I disabled the 8-minute delay option for my demo. Where can I configure it? So if you go to this repository right here, if you go to it's not under API, it's under templates.
Will you make that full screen?
Yeah. So if you go under templates, if you go under SRC, So here are all your project files under program.cs. Here you see delay between commands. So it's 4 delays of 2 seconds. So you can configure, just change this text into whatever you want, and you'll have your delay according to that.
Okay.
Just remember that it's going to be multiplied by 4 times. Sure.
Now you mentioned those like 5 like EDRs. Is there any more that you test against, or is it just those?
We often, okay, the question is, there are 5 EDRs which we tested against. Are there any more EDRs which we might have tested this against? We come across a lot of weird EDRs here and there, but these are the most common 5 ones, because you cannot bypass, let's say you encounter a weird EDR, let's say XYZ EDR, right? And if I can encounter it just once, I won't say that, okay, this has bypassed it, because it depends on the configuration of the EDR and what mode it is. But these are the most common ones which we have faced. So all these test results which you see, these are a byproduct of at least 5 or so detections or not. And I mean, when we talk about CrowdStrike, even in those 5 detections, if there are 5 instances of us running against CrowdStrike, if we come across, let's say, 3 times where it gets detected, we'll say that, okay, CrowdStrike detected this. But it might happen that on those 2 times you might get successful, because it all depends upon how the agent is configured, what's the sensor tuning and all that. Any more? All right, yeah, sure.
Chrome, Firefox, victims running either of those, this would not work.
Technically, it should, because when you download the .application folder, the .application file, most modern day browsers should have that built in. But in case they have older browsers, there is an option to add a .apprefms file. I might just add it in the future releases. So in that case, if you have that particular file, you send that to the victim. And the beauty of .apprefms files is you can embed them in documents as well. So you can get the same results using that. Right. All right. Any more? I guess not. Oh, sure.
But by the time that, let's say, CrowdStrike detects this, you've already achieved shell.
So that's a bit, okay, repeating the question. By the time CrowdStrike detects this, have we already got the shell? Is that the question?
Yes.
Yeah. So what we have seen is that, and it's a bit of a iffy situation, because again, EDRs are not really transparent about how they work. There are 2 cases. One is sometimes we don't get the shell because CrowdStrike outright blocks that run DLL32 call. That's the most common one which we have seen. If we have got eaten up by CrowdStrike 10 times, 9 times it's that one call, run DLL32. And there are multiple ways to go around it. It also depends upon your CD, how you configure your CDN, whether you have that on an internal network, because using this technique, you can also have it on a shared drive or on a server, right? Because as you can see, there's no URL parameter we can pass to the ClickOnce. So most of the cases, it's the run DLL call itself which gets caught. In the rest 1 out of the 10 cases, what happens is that we get the first initial beacon and the subsequent beacons get blocked. So this is a personal observation which I have made over the last month or so, that ever since the CrowdStrike incident of last year where Microsoft got bricked globally, they have been pushing EDR vendors out of the kernel as much as they can, and all modern detections are more or less relying on the network signature. So your network setup, your CDN setup, how you're domain fronting it is as important as your loader or the payload technique or the shellcode itself you're using. So that's a very crucial part right now, what we are seeing. I can give an example where we were using something. Have you guys heard of dev tunnels? It's a Microsoft if you're using GitHub, Microsoft provides you this option with dev tunnels. We were using dev tunnels for the longest time with amazing success, because it's a Microsoft thing, it has a good reputation. But recently we are getting more burnt on this thing. So your URL reputation is a very crucial factor whenever you're trying to use ClickOnce. So yeah, sure.
From a defensive perspective, what's an alternative method when these EDRs aren't detecting it? What can we do to establish some kind of detection?
Oh, a very easy detection is checking for example, whenever you run ClickForClickOnce Payloads, it runs under the app data directory. Now, it would be very suspicious to have something like PowerShell ISE running from a parent directory which is not System32. That's one. And also, you can check for this particular file, which is, I don't think I have it in here, but I should have a deployment somewhere here. Oops, wait. So I had a file deployed here somewhere. So let me download the zip file, unzip so I can show it to folks. So there is a .exe.config file, which is how app domain injection works. So that can be something which you can. I don't think I have it here right now, but you should be able to get it if you deploy a payload and look for it there. So that's a good detection. Another, I would say, good detection is unusual side loads, because PowerShell ISE won't load something which is not signatured. So, or you can sign those DLLs. If you guys want to further obfuscate this, you can use something like Obfuscator or any of those. Since this is .NET stuff, .NET framework, you can use those things to mangle this up and maybe detect that entropy.
Okay.
Any more questions? Yeah, sure. Okay. Okay, app blocker is okay. The question is this method getting past app blockers? Now, this is a beautiful question, because one of the biggest challenges of this thing is app blockers themselves. But there is one method where you can still use this thing to bypass app blocker, because essentially, when you run this thing, you get those payload DLLs and a .exe config file. Now, what you can do is you can use, you can just take those files, put it on a machine, and you can use environment variables to cause app domain injection, so that when you run PowerShell with certain environment variable set, it loads your payload DLLs instead of the way it's supposed to work. So even though you directly cannot use this to bypass app blocker, you can use the artifacts from this process to run app blocker. Sorry, to bypass app blocker. Any more questions?
Well, I just have one question
Yeah.
to wrap things up. I think at the beginning of this presentation, you were accused of being an AI agent version of John Hammond. So do we feel like this is different? Okay, great. Let's give our first-time speaker another big round of applause.
Thank you, everyone.